you've got to guess what the angle is, and it becomes a complete pain in the butt. All right. So here's the function I normally use for all of my rotation operations to make it so that this side is down, okay, or whatever the long side is. All right. I'm going to draw a box around the whole part to start, okay. And what I'm going to do is I'm going to come not to rotate, okay, but I'm going to use a line, okay. And when I click on a line, it's a 4-click process, okay. So what I'm going to do is I'm going to change my snap to start. I'm going to right click and I'm going to put it on endpoint. Okay. And now what I'm doing, I'm going to zoom in a little bit so you can see it.
The radius over
Right.
there.
I'm going to create a point here and a point here that form the line segment that I want to align with, and then I'll snap it to the grid after that. Okay. So 4 clicks. 1 click. 2 clicks. And now you'll see. I've got it from this point, and now I'm basically moving it around the part. I'm going to right click again, and I'm going to change my snap to grid. Origin, and just somewhere out there. Okay? So 4 clicks, but you change your snap twice, because you want to use kind of endpoint to snap that line wherever it is in space, and then switch it to grid to make sure you lock it to the origin. It's somewhere out here on the x-axis. Okay? On this machine. So we've got to rotate it. Alright? You do have a rotate function here. I don't like using it because if this side is out of square, you've got to guess what the angle is, and it becomes a complete pain in the butt. Alright? So here's the function I normally use for all of my rotation operations to make it so that this side is down. Okay? Or whatever the long side is. Alright? I'm going to draw a box around. So what I'll do here is I'll bound it. I'll say if it's 13 to 13.5, okay. I'll hit okay. And now, when you click on this, now you got your 13 millimeter.
You can select and put one time on.
Yeah, so basically, if they're all the same,
yeah.
if I just select all real quick, if I hold control and I click on one of them, it grabs all of them.
Just select and click on one.
Yeah, you control click and it'll get all of them at one time because it'll find everything that's a similar size to that. Okay? Whoop. Oh. So what I'll do here is I'll bound it. I'll say if it's 13 to 13.5,
I have to click on the wheel. I have to click on the drill.
Right here. And you can either increase the L value or you can increase the P value. Okay? Then we'll move it out a little ways. Okay? This is, yeah, one of those situations where if it's parallel with that profile, you might have to get a little bit creative with how you do that stuff. Now you gotta do the same thing over here though, so go back in. And like I said, if you just click here, just click once, let go, and then now you've got it on a swivel. You can put it wherever you want. Obviously, don't drop it in the glass, but you know. Looks fine to me. It's outside, so, and the machine's calibrated pretty darn well, so I'm not expecting any problem. Right here, with this line interrupted, okay? So normally,
You have to make the full line.
it works better when it's like that. So that load line goes the whole way, okay? And that'll be a AW issue or whatever. Because now when you come back in here and you click control, you get just that.
Okay.
With this line interrupted, okay? So normally,
You have to make the full line.
it works better when it's like that. So that load line goes the whole way, okay? And that'll be a AW issue or whatever. Because now when you come back in here and you click control, you get just that.
Okay. Okay.
You know what I mean?
That one is the bad.
It's either that
It's gonna
or
come like
have them
that.
draw the line.
It's gonna come like that. They cannot figure it out.
Be careful though, because you can miss profiles if you're not careful
Yeah.
doing it like that, or get too many by accident. So we'll draw the box.
Okay.
You can optimize it left to right or right to left.
Okay. So it's gonna go by like
This way or that way. Hey, I can't do top down. It'll be left to right or right to left. At least with the drill bits. So I think you have a couple more options with the milling and the profiling options, but for the drill bits, you can optimize it to go left to right or right to left. I mean, the thing for me is it's pretty rare that like it's just going this way, I guess is what you're saying, or is it going like here and then here? I mean, it's 6 of one, half does the other, you know. You can reorder it, but the software, especially when we start talking about doing like cutouts and stuff like that, it's going to reorganize most of that stuff anyway. You know, I don't generally recommend doing it. You can reorder it, but the software, especially when we start talking about doing like cutouts and stuff like that, I'm changing a couple of tools that we ran yesterday just to make them, because you guys are worried a little bit about the power. Might not fit the standard method of working, okay? So usually what we do, since it's got interruption, it's going to try to treat this as one part of the operation and that is another part of the operation. But what we can do is this is the lead in and that's the lead out. Lead in and lead out for the one that's currently selected, okay? So I can either type in new numbers here or I can click and drag around on the part, okay? So just to show new numbers, you got T, P, and L, all right? T is a value, so this is where the profile starts. T is a tangent number, so it's going to go, in this case, 15 millimeters down. P is a parallel or a perpendicular point off of that tangent location. So realistically, this might be a little bit close, okay? So what I can do is I can change the P value to 4, and hit apply, and then it'll move it away, okay? Or, if I didn't want to do it that way, I can leave that at 1 and change the L value to 4. And what it'll do instead of increasing the arc is it'll increase the distance that it comes and then moves directly to that point and then approaches the profile, okay? All right, that's when we're talking about tangent. Now, just so you can see the other lead-in styles, we have none, which is basically saying we're going to march directly to that line based on an L value and then start milling away, okay? I don't normally use that one unless I absolutely have to get into some obscure tight space, okay? We have linear, which is very similar to tangent, except instead of this being an arc right here, this is just saying, all right, we're going to come here, and then we're going to march our way straight to that line, and then we'll make up the difference when we get to it, okay? All right, perpendicular. Ain't nobody using perpendicular in their life. I don't know why or how, but you can change it. I mean, we can make it look like that, but nobody really uses perpendicular, okay? And then the last one is the one we normally use, and that's tangent, okay? And tangent right now is all screwed up because I moved everything around. But just so you can see the click and drag options though, if I don't type in numbers directly, okay? If I click on this portion of it, I can adjust my T or my P, whichever ones are available to me, okay? And I can go anywhere I want and make this tool do anything I like, okay? However, Obviously, don't do something like this. That'll cause some major headaches for you, okay? It's all about trying to get that tool in and out safely. So we'll move it away from here. If I click here on this line, now I can adjust my L value, okay? And usually I just move it as close as I can to that point. I'm not usually too concerned about the L value being large, all right? There's your lead ins, okay? Now, on your lead out, this one's a little bit different because what we're trying to do here is create a little bit of a circle or a cutout larger than the diameter of the tool so that we wallow this little area out and then make a lift, okay? So when we do that, it's going to end up looking like this where it goes negative in this T value because it wants to get back over to this point right here, all right? Now, since we were talking about the idea of trying to actually break this into two separate chunks instead of making it so that the piece comes out in super long sliver, because I think that might be part of the reason that piece chipped, okay? What we can do is we can modify this and either change the lead out style in general or just grab the tail and move it out here. In which case, it's going to come in and then it's going to find a way to completely exit the glass so that this sliver falls independent of that sliver, okay? Which might give us a little bit better chance, okay? Because the other thing to keep in mind too is not only is there a potential where if the piece is large, cut on the glass, that it's going to like rotate, kick it down here, all right? Unlike your horizontal CNCs, your Intermax, they got those pressure vessels, okay? And they're moving, okay? So if this piece is held firm somewhat by those pressure pads, even if it doesn't fit, if the pressure pads have it, it can pull that piece down and kick it out. Like this, okay? Worse if it's heavy. Or surface area for it to grab on. Might not fit the standard other one, it would do the same thing. It would go like that. So just hit OK. And then now, that chunk should come out, and that chunk should come out separately. The other one, it would do the same thing. It would go like that. Get from that style. So what we're going to do is right now I'm on the bottom cut. I'll just change it to none. Okay? And none only gives me the L value. So now what I got to do is type in a value that's going to get it outside the glass. Okay? So I'll type in, I don't know, 35 or 40, for example. I hit apply. And now it's going to march its way up and then on center move out that way. I can do the same thing for the other one. Come up here. Don't like that style, so maybe I'll put it on none. Forward it. Apply. And get from that style. So the other one, put it on there. Put that one around. Apply. There's a couple different methods you can do. The other one, put it on there. Put that one around. Profile, set the box. So now it knows more glass around the outside. Okay, now tell it up, take this. Okay, now you're good. No. Profile, yep, expand it. Flat edge 10. It's going to start there. I mean, you can start anywhere. A lot of times I start on this side. But if you want to change it, you can change it right here. So change start, and just click in that lower corner. It'll start right there.
All three tools, right?
Yeah, all three tools will start in that location. That's close. So here, maybe we do it this way. Click here. But instead of that being 30, change that to like 20 or 15. Is it okay? I'll give you a little bit of space. Yeah. Otherwise, we probably should take them off. You know what I mean? So that should probably work okay. Profile, set the box. So now it knows more glass around the outside. Okay, before you start, put this one on reference stop too, so it uses the other one. Okay. Alright. And then let's get that piece of glass off.
Ini dapat
Okay, before you start, put this one on reference stop too. But at a certain point, if the overhang becomes too much, the key and the software can sync up. So in something like this, you're better off taking it and mirroring. Yeah, you go right here. It doesn't really matter. Software knows the height of this physically, and so if we run this first piece and it hits hard on this side and doesn't hit it on the other side, I've got to adjust this up in my head. But at a certain point, if the overhang becomes, I go in here. This is more for me, but in here, this is how the software knows some of the physical positions and limits for the machine. So for example, X position for stopper, distance of glass position on an overload set, like a lot of these things are in here. So as far as what I need to change or modify and stuff like that, they all get set up in here. And this here, where is one of them?
This one, it doesn't matter. We have a network.
Not good. Position and the stroke of the stopper is right here. So I can change it. Right now, it's set 11. I go in here. This is more for me, but in here, this is how the software knows some of the physical positions and limits for the machine. So for example, X position for stopper, distance of glass position on an overload set, like a lot of these things are in here. So as far as what I need to change or modify and stuff like that, they all get set up in here. And this here, where is one of them?
This one, it doesn't matter. We have a network.
Not good. Probably if I make this a little bit like that, 11 is Might have done it. Okay, so it calculates the base on that. Not really. Okay. That's what your 20 millimeter is for your safety valve. Might have done it. Okay, so it calculates the base on that. Not really. Okay. That's what your 20 millimeter is for your safety valve. Might have done it. Okay, so it calculates the base on that. Not really. My endpoint. Now we'll go back to grid. And now you've got the other side on the bottom.
No, yeah.
Now you got 974 on the bottom. 970. Do what? You're fine. Yeah, you should be okay. Your clearance is like right here. So here, let's check it real quick. All right, hold on. We gotta undo all this. Sorry. We rotated the whole thing. Let me just look at it real quick. We're good. Go ahead and do your programming again, though, if that's the way you want it to be.
Insurance guy is coming tomorrow. Is he coming to see you too at the same time? Insurance, building insurance, coming to see me at 10:30.
Yeah.
For this class, my endpoint. Now we'll go back to grid. Now you've got the other side on the bottom.
No, yeah.
And now it's fine. And now it's fine. Machinings. This has the sum of the parameters that are basically like underlying even the tooling and the kits, okay? So what I just changed a second ago was in edging. I've got a lot of core values. You got to be careful with when you're changing. Like for example, the safety distance. That's the distance it's going to try to get the tool away from the glass before it moves into some other area. All right, but the one I just changed was fillet radius on external sharp edges. Basically, so if you've got corners, so this is the piece of glass, how much of a radius do I want to add at those edges to ease them a little bit and basically dub them? By default on every piece. So it doesn't matter if the drawing has a perfectly sharp corner, it's going to dub or fillet 1 millimeter on every sharp corner. So, anyway. Machinings. This has the sum of the parameters that are basically like underlying even the tooling and the kits, okay? So what I just changed a second ago was in edging. I've got a lot of core values that you got to be careful with when you're changing. Like for example, the safety distance. That's the machining. This has the sum of the parameters that are basically like underlying